I'm filming another video dealing with coins. This time, we're dealing with 5 different sets of 100 coins. As you might already know, I've done videos where I show how to do various analyses, or how to display, or how to calculate certain values associated with these. Each of them does involve $100 worth of coins. This time, though, I'm using 5 sets and using just one bit of information from each set. I've labeled these batches in my Excel file here. And so each of these batches consists of 100 coins. And in this column here, I have the number of those coins that are Sacagawea coins. So again, these 100 coins that form these batches, in this case, are all dollar coins. So, well, I should say I ordered dollar coins. There was one case in there of a Canadian dollar, and there was one case of a Austrian 10 shilling coin. But those were in rolls of what I ordered to be dollar coins, so I'm still counting them as dollar coins. Anyway, so what we're going to do is, with these 5 data values, we're going to find the arithmetic mean, which is often just called the mean, but technically there's more than one mean. So we're going to find the arithmetic mean of those, the median, the standard deviation, the minimum, the maximum, the sample size, which obviously is just 5 in this case, but if you had a really large set of data values, then being able to calculate the sample size is nice. And then we're going to find the first quartile and the third quartile, and we'll be using the inclusive calculation for those. I'll talk more about that when we get there. Okay, so to calculate the arithmetic mean, one thing that's really annoying is Excel just uses the word average for that. That's annoying because average is a catch-all term. The arithmetic mean, the geometric mean, the hyperbolic mean, any mean, the median, a 10% trimmed mean, okay, any measure of center is technically an average. So this is a little annoying, but oh well. As before, I can either select them by clicking and dragging, or I could actually type these numbers in. I should say labels, not numbers. So B2, right, this is column B, row 2. Colon is saying everything from B2 to the next label, which is B6, and that's column B, row 6. Okay, so close my parentheses and press enter, and we get that the arithmetic mean of this is 49. And so essentially this is why the word average is used in here. You can say this as on average, out of $100 coins, 49 of them are Sacagawea coins. However, that's not well defined. If you just say on average, blah, no one knows what you actually did to calculate that. So if you want to be precise so that people know exactly what you're talking about, you say the arithmetic mean number of Sacagawea coins out of $100 coins is 49. Okay, for median, this one's a lot nicer. It actually is labeled as the median. Okay, and it's the same set of data, so I can type it in the same thing that we used before, or I could select it and press enter. Okay, and so like I said, median is another kind of average, so I could also say on average there are 47 Sacagawea coins out of $100 coins that I get from the bank. And again, that would be perfectly fine, because average can mean arithmetic mean. It can also mean median. So if we want to be precise, we would say the median number of Sacagawea coins per $100 coins that I got from the bank is 47. Okay, now the standard deviation. Standard deviation is a measure of spread instead of a measure of center, so this would not be considered an average. Now, if I start typing this, STD, standard deviation, okay, DEV for deviation, notice that there's a whole bunch of options here. We're going to use the standard deviation .s, okay? The S in there, the S after the dot, says I'm dealing with a sample, not a population. The formulae for standard deviation, there's two of them, that's why I say formulae and not formula. They have a different denominator depending on if you have a sample or a population. I'm not going to go into that now. That's not the point of this video. The point of this video is to show you how to do this stuff in Excel. This is not a statistical lesson on the differences between the standard deviation of a sample and the standard deviation of a population. All you need to know is that the standard deviation of a sample is calculated by typing in stdev.s. Okay, and then it's the same set of numbers, so I write those same values in, press enter. Okay, so now I have 3.24037, etc. as my standard deviation. Of course, if I want the variance, I could just square that. I'm not going to bother with that right now. In another video, I did show how to use the minimum and maximum functions. But just in case you haven't watched that, let's just do those really quickly. So minimum is just min, and then maximum, as you likely have figured out, is max. Okay, so the fewest was 46, and the greatest was 53. Okay, that's a very small range of values. Okay, for anybody who doesn't know what I mean here, the range for a data set is just the maximum minus the minimum. So you can just take maximum minus the minimum, and that gives us the range. So 7 is our range, and when you're talking about 100 coins, that's a pretty small range. Okay, let's go back over here though. Okay, the sample size. Again, I could just say, oh, well, I have 5 values here. But what if I had 5,000? It'd be nice to have a way of calculating that without having to actually, just count them physically here. So what I can do is, in a previous video you saw me use Countif. Now I'm going to use Count A. Okay, and this is just going to say, how many values, how many cells actually have something in them. So I could just select this region here, okay, and it says 5. But what if I went even bigger than that? Like, let's say I wasn't sure. This was a really big data set, and I just went way farther than I needed. Okay, let's do down to 16. That's not way farther, but it's enough so you can see what happens. It still gives me 5. Okay, so that's a quick way of calculating sample size, even if you don't know exactly how far your data goes. Okay, now, first quartile. So notice if you type in quartile, it gives you options of .exe and .inc. EXE stands for exclusive, and INC stands for inclusive. Basically, I'm using INC for inclusive because that's the one that's more popular. Let me show you what that produces. Oh, I've messed something up here. Oh, yeah, I need to say which quartile. It's first quartile. So I put in my range of values here, and then I have to say it's the first quartile, so I put a 1 after the comma. Okay, so I get 47. Let's say I did the exclusive one. Okay, same array, still first quartile, okay. This time I got 46.5, okay. So, I guess I shouldn't say that inclusive is more popular. It's the older one. If you... sorry if there's noise in the background. I have cats running around. If you were to use Excel a long time ago and just use quartile, I'm pretty sure that the inclusive one is what it's calculated, okay? It basically has to do with the fact that it's based off of a percentile, and percentile they allow from as low as 0 up to 100%. They include the 0 and the 100%. So what this means is let's do a little experiment here. If I put in a 0 there, notice what that gave me is the minimum, okay? Because it allows you to include the lowest, the start of the lowest quartile. But if I use the exclusive, and put in 0 as my quartile, it gives me a number error. Okay, so that's the difference between them. The exclusive one is what you're more likely to get if you calculate it the kind of low-tech way by just writing them in order, and then when you take the median, which in this case is 47. And then you look at the two lowest values, and the two lowest values are 46 and the first 47. And then you take the mean of those two values, which gives you 46.5. So anyway, they're both used in various ways. I'm showing the inclusive one here, but obviously it's perfectly fine to use the exclusive one. If you were doing this for an analysis, you would just make it clear which one you're using. That's true for a lot of stuff in statistics. There's a lot of things that there's multiple ways of doing it, and you get to choose which one. You just have to be clear as to which one you're using. Okay, let's do the third quartile. Okay, same array. And then I need to say I want the third quartile. I'm not bothering with the second quartile because that's just the median, right? So my third quartile is 52. Okay. And of course we could calculate all sorts of other things. I could calculate percentiles, which you're probably not surprised to see that this is just percentile and then .exe or .inc, and then you would just pick a number between 0 and 100. And if it's the inclusive one, you're allowed to pick 0 and you're allowed to pick 100. If it's exclusive, those will give you errors. So that is it. I hope this was helpful.